Sarai. Let's do the quadrantal angles in degrees. Ready, set, go. Oh, you can't see anything. Sarai, where is 210? Which quadrant? Thumbs up, thumbs down? Yep. 90, 180, somewhere in here. Yes? This is where the terminal side is. I started in standard position. Now, I like to write my angle right here. Class, what's the difference between 210 and 180? 30. So this is a 30. What's the difference between these two? 60, right? Do you see it? The complementary angles? Blank plus blank equals 90. Jacqueline, how do I draw the triangle? Should I go up or to the right? Up. Yep. Think of your bow tie. Phones are off. So class, what kind of triangle do we have? 30, 60, 90. Rochelle, tell me the formula for 30, 60, 90s. So I'm going to highlight that this is a 1, radical 3, and a 2. Put this on your formula sheet. Memorize it. This will always be the case. All right, let's label this now. Chen, across a 30, what number am I going to put across the 30? Your choices are 1, radical 3, or 2. What letter is that? X, Y, or R? So look at this. This is going... It's up and down. It's parallel to Y. Is it positive or negative? Correct, because it's going down. Chen, how about this side? On the x-axis, what number? Remember, look what it's across. Yep, across the 60 is a radical 3. Positive or negative? You're going to the left, right? So negative numbers. And Chen, this one is called your radius. What's your number? Yep, it's across the 90, so it'll be a 2. Positive or negative? Always, right? Okay, so let's summarize what we've done so far. We're asked to find 210 degrees. We know this is 180, this is 210, so our reference angle, theta prime, is 30 degrees. This is the angle that's inside your triangle. Remember, think of the bow tie. We labeled the sides of the triangle based on what's opposite of the special right triangles. Okay? And now we're going to find the 6 trig functions. Daphne, tell me letters. Sine? Numbers? So that just becomes negative 1/2. Daphne, cosine? Yes. Numbers? Yeah. Tangent. Partner A, tell partner B, how do you rationalize? Noor, how do you rationalize? Yep. So that becomes a negative times a positive expression. 1 times radical 3 is radical 3. This is radical 9, which is 3. And then we just need to find the reciprocal identities. We're just going to flip these, right?
Mr. E?
Yes?
Shouldn't the 10 be positive?
Tangent.
Negative 3 and negative 1?
Up, thank you. Class, if Mr. Hallenkar came in here, he would tell us what? So we can double check. Class, what does this mean? Tangent and cotangent are positive. Everything else is what? These will all be negatives. Negative, negative, positive. Now the great thing is if you've already done sine, cosine, and tangent, then you can just flip them and find the reciprocal. So I have negative 2. This one's not going to be fun. If I flip this, I'm going to have 2 over radical 3. And we're going to do the same thing, rationalize. You're going to get negative 2 radical 3 over 3. And then right here, you already have your answer. If you just flip this one, you're going to just have radical 3. Positive, right? All right, that was a lot of work, wasn't it? It was a lot of work because we drew the triangles. We had to make sure the positive and negatives, right? There was no order pair. So we had to use the special right triangles, and then we found them. And then this trig paper plate came along. Let me show you guys how fast cosine of 210 is. Put your finger at 210 degrees. There it is. I wanted cosine. Cosine is the first order pair. Cosine, sine. So cosine is, the answer is negative radical 3 over 2. That was it. Did you see how fast that was? You like blinked. You didn't know. Okay, let's try another one. Let's try tangent. Okay, tangent's a little bit trickier. Watch this. 210 degrees. We already know that the answer is radical 3 over 3, or negative 1 over negative radical 3. How do you get that? Tangent is, this is cosine, this is sine, and tangent is y over x. Are you following along? So this is the y. That's a negative radical 1, or negative 1. And this is the x, negative radical 3. So tangent is negative 1 over negative radical 3. And you rationalize that, you get this as your answer. Okay? That means in 2 chapters, we're going to learn about the identities, that basically tangent is sine over cosine by the quotient identity. Okay, you don't need to know that for now, but you need to know that tangent is y over x. Let's do one more. Let's do cosecant at 210. Cosecant is r over y. So essentially, you would just take this as your sine and just flip it, right? 2 over radical 3 negative, and then, what did I say? Cosecant. Oh, yeah. Would have been this one. And then you're flipping this one. That would give you your negative 2. So, question. Raise your hand if you like the paper plate better. Okay?
Why is the 210 in the paper plate? Why is there a root?
it was one of my counting techniques. But let me finish this really quick. Raise your hand if you like drawing the pictures. The triangle's better. Okay? If I had a preference of what I would want you to do, I would want you to do this. Because you can kind of conceptualize and see the special right triangles. This basically has all of the special right triangles. Okay? You can memorize it, and you guys watch my video. Hopefully you see the counting techniques. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Take the square roots of all the numerators, and they're all divisible by 2. If you go onto YouTube, there's multiple tricks. There's ones with your fingers. I saw one with a chart. You can use any of those, but this is probably the strongest. In today's lesson, if you could do both of them, I'm super happy.